Hello, am I audible and is my screen visible? Can anyone please let me know? And is my screen visible?
Yes.
Okay, thank you. So good evening everyone, welcome to this NPTEL live session for the course Deep Learning IIT Ropar. This is my third live session. My name is Learning-IIT. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this week's live session we will discuss some questions on week 3 topics. So in week 3, multi-layered perceptrons and backpropagation, these are the topics that were covered. So we will discuss some questions on backpropagation and also MLP. And if you have any questions or queries regarding the topics covered this week, you can ask me during this session. Okay, we will start solving some practice problems, and after that, if you have any questions or doubts, you can ask me. So this is the first question. So a neural network or multi-layer perceptron neural network is given. This is the neural network, and as you can see, there are two hidden layers and one input layer, one output layer, and the input is three-dimensional. Input vector is of length 3 basically, and the loss function used is this, the predicted value of y minus true value of y squared. So now what are the dimensions of w1, w2, w3? So these are the three weight matrices. So w1 is the first weight matrix, w2 is the second weight matrix, and w3 is the third weight matrix. And assume that we are excluding the bias terms, so we are only considering the weight matrices. So what are the dimensions of w1, w2 and w3? You can write your answers in the chat. Rakesh says w1 is 3 cross 3, w2 is 3 cross 2, w3 is 2 cross 1. Himadri Yogi also says the same, 3 by 3, 3 by 2, 2 by 1. Kimberly Moraes says 3 by 3, 2 by 3, 1 by 2. Okay. Kajal says 3 by 3, 2 by 3, 1 by 2. Anyone else? So for the first matrix W1, for W1 there is not much confusion because there are three units in the input layer, and also there are three units in the hidden layer, first hidden layer. So it would be 3 cross 3. Now for W2 and W3, you have to be mindful whether it's number of hidden layer in the next layer by number of hidden layer in the previous layer, or number of hidden layers in the hidden layer in the previous layer by number of hidden layer in the next layer. So which dimension comes first? So the convention that has been used in this course is that number of units in the next layer into number of hidden layers in the previous layer, so that we can calculate like this. So H equals W into X plus B. So this matrix multiplication W into X should be compatible. So for that, so W2 is actually 2 by 3, 2 in the next layer and 3 in the previous layer. So similarly for W3, there is only one input in the output layer and there are two inputs in the previous layer, so 1 by 2. So these are the dimensions of the three weight matrices. So number of units in the next layer into number of units in the previous layer. So this is the convention that has been used, so that this matrix multiplication is possible for every layer. It is only for the first layer, and after that you would do W. So for the first layer, W1 X plus B. For the second layer, it would be W2 into A1 plus B. A1 is the activation of the second layer. Then W3 into A2 plus B. So that these matrix multiplications are compatible, you need to have this dimension convention, that number of units in the next layer into number of units in the previous layer. Is there any doubt in this question? Okay, so we can move on. Now for the same setup, for the same network, now we have given W1, W2, W3 values, and so W1 is 3 cross 3 and W2 is 2 cross 3 and W3 is 1 cross 2 matrices, and input X is a three-dimensional vector 1 1 1, and the target value Y is Y equals 10. So what is the predicted output of the given input X after doing the forward pass? And for this you can assume that for the hidden layers we are using sigmoid activation function. So here we are using sigmoid, here using sigmoid, and the output layer we are not using any activation function. So it is linear activation you can consider in output layer. Kajal says 6.92. Okay, it might have been already discussed in some previous live session, otherwise it would not be possible to answer so quickly. Those who haven't tried it yet, or those who haven't solved it previously, you can try. this calculation will take a lot of time, so I will just show you the steps that you have to follow. Otherwise you have to compute this matrix multiplications, then you have to compute the sigmoid of those, so it would take a lot of time for this discussion, for this live session. So first, so H1 is, if H1 is the hidden unit value of the first hidden layer, so H1 is computed by W1 X1, and we are not we are assuming that we don't have any bias terms, so we are ignoring bias terms. W1 X1, so this is a matrix multiplication, so it would be 1 1 2, so this value is given there, and 1 2 3 multiplied by 1 1 1. So this matrix multiplication you have to do first. Then after you compute this hidden unit value, now activation value would be sigmoid of the hidden unit value. So sigmoid of H1 is the actual activation value of the first hidden layer. So now this activation value is propagated to the next layer, not this H1. A1 is the value that is propagated to the second hidden layer. Now we will use A1 to compute the hidden unit values of the second layer. So H2 would be W2A2 W2A1. so W2 is given there, W2 is here given, 2 cross 3 matrix, and you will get A1 from here, which would be a I think 3 cross 1 matrix it would be. And then you have to again take the sigmoid, because both the hidden layers are using sigmoid activation functions. So A2 would be sigmoid of H2. So sigmoid will be computed element wise. So if for example H2 is a 2 by 1 matrix, so sigmoid would be multiplied on both the elements of the 2 by 1 matrix. Now this is the activation of the second hidden layer. Now finally we will compute the output layer. So the output layer would be y hat would be W3 into A2, and as I have already told that output layer is not using any activation function, basically linear activation or no activation you can consider. So though no activation function is required, so we just have to multiply the weight matrix W3 with the previous hidden layer activations A2. So W3 A2 is the y hat, which is the predicted value for the input X. So this is how stepwise you have to calculate this output for a given input. You have to multiply the input with the weight matrix, then compute the sigmoid, then the activation is propagated to the next layer, then again use that activation and multiply it with the next weight, and then again compute the sigmoid. And this is how you have to compute the output for a given input X. So the two hidden layers are using sigmoid activation function, but the output is not using any activation function. But if output was using some other activation function, you would have to apply activation function like G of W3A2. G can be any activation function that will be given in the question. In this case it is not using any activation function. Is this understandable? Is there any question or doubt regarding this answer? Okay, so I have written the steps here. So this is how you have to compute. The output is 6.92 for the input X equals 1 1. Now question 3, for the same network and same weight matrices, and again the two hidden layers are using sigmoid activation functions. The output is not using any activation function, and for the input x 111, y is 10, target value y is 10, and you have to compute the loss between the output generated by your neural network and the true output y. So what will be the loss value if the target value is y equals 10? So we have already computed the predicted value in the last question. Now what will be the loss between the predicted value and the true value? And we have told in the first slide, where we first described the question, where it is using it is predicted value of y minus true value of y whole square. This is the loss function that we are using. Kajal says 9.44. Okay. So this question is much easier than the last question, because here we already have computed the predicted value, which is 6.922. This is the predicted value. Now you have to use this predicted value to compute the loss for this input. Himadri says 9.474. Okay. Anyone else? The loss value is given by predicted y minus actual y whole square. So this is the loss function that we are using. Sometimes this half is used, but in the question I have already mentioned in the first question that this is the loss function that we are using. So predicted y for this input x, we have already computed in the last question. It was 6.922. So this is 6.922 minus actual y or the target y is 10 given in this question. So this is the answer, 6.922 minus 10 whole square. So it would roughly come out to be 9.44 something, or 9.474 could also be the answer. So roughly it is around 9.4 basically. So 9.447 is the answer. Yeah, it almost 9.4.
It won't be squared. Square was there.
Yes. Can you repeat your question?
There is square also, na?
Yeah,
Square.
after computing this square, this is like what? I mean, almost 10 minus 7, isn't it? This is almost 7, 6.9. So almost 10 minus 7, which is 3 squared. So slightly more than 9. Yeah. Now question 4, again on the same question setup for the same neural network, and also for the same input x and y. If we call the predicted y as y hat, then what is the gradient dl dy hat? L is the loss function. So dl dy hat for the input point that we are using. So input point is 1 1 1, and target output is y equals 10, and y hat we have computed as 6.922. Then what will be the value of dl dy hat? Basically the gradient of the loss function with respect to the predicted value y hat. And the loss function we are using is the squared loss function, y hat minus y whole square. Himadri says option C, Kajal also says option C. So option C is minus 6.15. Jivana Sandhya says option C. Okay. Anyone else? So L is y hat minus y squared. So if we compute the derivative of this with respect to y hat, or the gradient of L with respect to y hat, so it will be 2 into y hat minus y. Yeah, this is the gradient. Now we know that y hat is 6.922, y is 10. We just have to plug in these values here. So 2 into 6.922 minus 10. So it would be slightly more than 6. So yeah, it would be C, minus 6.15. So you just have to first compute the derivative of the loss function with respect to y hat, and then put the values that you have already computed, y hat y, and you will get the gradient of L with respect to y hat. So this is not x, this should be into. I will rectify it later. Now question 5, again on the same question setup and also the same neural network. What is the sum of the elements of gradient of W3? This is not exactly gradient of W3, this is dl dw3, or sometimes it is written as gradient of L with respect to W3. So what is the gradient of the loss function with respect to the W3? So this is W1, this is W2, this weight matrix is W3. So W3 is a 2 by 1 matrix, 1 by 2 matrix. So you have to compute the gradient of L with respect to W3 and then take the sum of all the elements of that matrix, or the vector it would be actually. Kajal says option D. Okay. So W3 is a 2 by 1 matrix, so it is written as it can be written as W3 as W31 W32. So as it contains two elements, W3 vector contains two elements, so the derivative of the loss with respect to W3 would also contain two elements, so that would also be a vector. So this would also be a vector. So gradient with respect to W3 would be gradient with respect to W31 and gradient with respect to W32. So this gradient with W31 is basically this, and this is del L del W32. So del L del W31, how can we compute this? So we can use chain rule for this. Del L del Y hat and del Y hat del W31. So this the Y hat is dependent on both W3 and W1, because Y hat is computed as W31 A21 plus W32 A22. So if the activation of this is A21 and activation of this is A22, so this is Y hat W31 into A21 plus W32 into A22. So del L del Y hat we have already computed in the last question here. This is what we computed in the last question. And this del Y hat del W31, what is the derivative of Y hat with respect to W31? So using this equation we can compute this. So we take the derivative of both the sides with respect to W31, so only A21 remains. So this is del W31. Similarly, if we compute del W32, it would be del L del Y hat into A22. Yeah, so this is how you compute the two components of delta W3. So written here. So this is the gradient of W3 contains two components, gradient of W31 and W32. W31 is this one, A21 into dl dy hat, and this is gradient of W32, which is A22 into dl dy hat. So activation of this is A21, activation of this is A22. And so this activation values we have computed previously in this question here. To compute the output for this input X, we had to compute all the activation values of the hidden layers. So there we had already computed A2. So this is A21, this is A22. We had already computed these two activation values, and this is gradient of the loss with respect to Y hat, which we computed in the last question. Here we computed. So we just have to multiply these two quantities, and the output would be this one, minus 6.039 and minus 6.106. And question asks the sum of the elements, so you have to add these two elements and the output would be close to minus 12. So this one, minus 12.14. So we can go even further to ask gradient with respect to W2. So this is W2, this was W3, this is W1. So then again you have to use back propagation to compute, which would be a little troublesome. I mean a lot of calculations would be required, but for W3 calculations are much easier. So these are the only two equations you need to compute the components of the gradient of W3. So is this solution understandable? Is there any doubt in this question or solution? Okay, we can move on. Now question 6. Suppose you have a problem where the data x and level y are related by this equation, y equals x square plus 1. Which of the following is not a good choice for the activation function in the hidden layer if the activation function in the output layer is linear? So activation function in the output layer is already linear, we know. Then what is not a good choice for the activation function in the hidden layer? So options are linear, ReLU, sigmoid, tan inverse of x. Kajal says option A. Okay. Anyone else? This question is much easier than the last few numerical questions, so all of you should know the answer for this. The correct answer is linear. Linear activation function is not a good choice for the hidden layers if the input and output are related by this equation, y equals x square plus 1. So x and y are not linearly related, so they are quadratically related. So if we apply linear activation functions in the hidden layers, and output is also linear activation function, so it would simply learn a linear function. It would not be able to learn any non-linearity in it, but the relation is non-linear here. So linear is not a good choice for hidden layer activations. Now question 7. In regression problem, which of the following loss function will be used? So it should be will be used. Squared error loss, cross entropy, none of this. Himantri says option A, Jivana says option A. Okay. Vandana says option A, Sushma says option A, Kajal says option A. Dr. R. Kotteswaran says option A. Yes, so the correct answer is option A, squared error loss. For regression problems, we generally use squared error loss, and for classification problems we use cross entropy loss. Question 8. Which of the following method is used at the output layer for classification? Method or activation function, you can assume. Linear, softmax, linear or softmax, none of these. Mandana says option B. Dr. R. Kotteswaran says option B. Himadri says option B. Sushma says softmax. Jitendra says option B. Yes, so the correct answer is option B, softmax. For classification, in the output layer we use softmax or sigmoid activation functions based on whether we have only two classes or more than two classes. If you only have two classes, then sigmoid. If you have more than two classes, we use softmax. And linear is not used in place of classification, because if we use linear, there is no bound in the output, so it can range from -infinity to infinity, which is not ideal for classification. But for regression we might use linear, but for classification we don't use linear. So option B is the correct answer. Now question 9. The probability of all events x1, x2, x3, xn in a system is equal. So for each of these events the probability is equal, n is greater than 1. What can you say about the entropy Hx of that system? So log base 2 is used here. So this random variable x can take these values, x1 or x2 or xn, and each of these events has equal probability. Kajal says option C, Shushma says option B, Jitendra says option C. Okay. Dr. R. Kotteswaran says option C, Himadri says option C. So the entropy H of x for this random variable x is computed as negative of, we can put the negative inside also, negative of the probability of the ith event xi and log of p of I base 2. So this p of I is 1 by n for every I, because each event has equal probability. So pi is 1 by n for all I. So this would be, this is over I, so minus 1 by n log base 2 1 by n. So this is so this negative this negative can be used inside this log to make it log of n only. So 1 by n into log of n base 2. So this is log n into 1, which is certainly greater than 1. So log n is a constant which we can take outside the sum, and inside the sum we would only have summation over 1 minute, 1 by n summation log of n. No, we can't do that. Summation over 1 by n log of n divided by n. So I was 1 to n. So this log of n divided by n summation over 1 by n. So this is greater than equals 1. And if the h of x entropy would also be greater than equals 1. So if each event has probability equal probability, then the entropy of the whole system is greater than equals 1. So yes, so this is written here. So yeah, so these were the questions that I wanted to discuss in this live session. And now if you have any other queries, you can ask me.
Can we ask for questions from previous assignments which have been evaluated?
Previous assignment, yes, you can ask. But I haven't seen the previous assignments yet, so I have no idea what kind of questions were there. And does anyone have any other question?
I have posted the question from previous assignment.
Is it x cube minus 4x square plus 7? So
Yes, it's x cube. Yeah, it's x cube, x square. Yeah.
So the similar question I discussed in the last last live session. So you have to take the derivative of this fx with respect to x.
I followed the same method, but my answer is wrong. They have made it.
I mean, in their solution PDF, did they solve this question properly?
Do we get any solution PDF? It's just
Yes.
right or wrong. That is Magna for
No. In the portal, you will get under every question, but there is a solution uploaded for every week. There should
where
be.
is it uploaded?
There in the left hand side you will get week 1, week 2, like this. Under week this was from week 2. So if you click week 2, you have all the lecture videos, names of those lecture videos, and then you have week 2 assignment. After that you will have solution for week 2 assignment or something like that. For every week there should be a solution document.
After that is no, it's only the feedback form that is there.
They might not have uploaded it yet in that case, but the method here is that you take the derivative of fx with respect to x, which is easily computable here. It's 3x square minus 8x. This is the derivative of fx with respect to x, and now the initial value is 5, so x is updated as x equals x minus, so it has to be minimized, right? Was it mentioned in the question? I think it is to be minimized. If it is minimized, so it would be
Yes.
x minus alpha, which is the learning rate, and f dash x. So initial value of x is given as 5. So if you compute f dash 5 and you have alpha, you also know the initial value 5. That is the first iteration. Now you will get a new value x1, let's say. So now you will get you will compute again this thing f dash x1. This is after the second iteration. You just have to compute this. I mean, the solution would be uploaded eventually. I think they have not uploaded it yet, so their step-by-step calculations would be given. And the overall method is like this: just you update the value of x. X is the parameter here, so x is the parameter that would be updated in every iteration.
Yeah, I followed the same method, but it's just mentioned that the answer is wrong.
You can compute it again. It will take some time, so because there are many decimal points and something like that, so and square cubes you have to compute, but this is the overall method. And if it is I mean, after the solution PDF is uploaded, you will be able to see all the steps properly. This is the method. If you have used this method, then this is right, but some calculations mistakes might happen, so in that case it would be marked as wrong. In approximate using 250 tower functions, what is the minimum number of neurons required to construct the network that approximates this function? Answer is 20.025. So answer of this question, this tower functions question, was 20.025. Shouldn't the answer be 250? I think what should be the answer here? Answer is 501. I also don't know how to compute that. No, I right now I can't think of how to compute that. No, you have to you can ask in the discussion forum. The TAs and the instructor who created these assignments, they would be able to answer questions related to these assignments better, because these questions have not been created by the live session TAs. These have been created by the regular TAs and the instructor. For this MP neuron question, this should be easy, isn't it? x1, x2, x3, x4, x5, theta is 3, and where x5 is inhibitory input. For input 11101, what will be the value of y? So MP neuron simply takes the sum of all the binary inputs that it has, and if the sum is greater than the threshold, then it outputs 1, otherwise it outputs 0. This is how you compute output for MP neuron. Was there any doubt in this MP neuron question? This looks straightforward. Vandana, you have posted it in the chat.
Yeah, because according to me here, y equal to 1 since theta greater than equal to 3 should be the answer. Because theta is 3 with 1 plus 1 plus 1 here in the input. But they have said y equal to 0 is the correct answer.
So x5 is the inhibitory. So if for inhibitory inputs, do we have to take the complement of that, or what? Was anything mentioned for this inhibitory input?
For inhibitory, it will be 0, I believe.
So even if it is 0, there are 3 other inputs which are 1. So it's still 1. The sum of all the inputs would still be 3. So that is greater than equals the threshold.
So according to me, this is the right answer, that y equal to 1 since theta greater than equal to 3. But they marked it wrong, and the correct answer is y equal to 0.
And then again you have to wait for them to reply. Did you ask any question regarding this in the discussion forum?
No, so we should raise
you
this
should
in
you
the
should post it in the
forum.
Discussion forum. The TAs who created the questions and they created the answers, they would be able to answer the reason behind this. Why
Okay.
this? I'm not completely sure why this should be y equals 0. I mean, this inhibitory input does something, I don't know. The inhibitory input means it becomes -1, is it? I'm not sure.
Yeah, in other questions it was 0. I don't know.
I'm also not sure. So you can post in the discussion forum.
Okay, thank you.
Kajal has written, what is the output of the perceptron with weight vector this and bias this when the output is 1 0 minus 1? You just have to multiply W with X and add B. Yes, this is how you calculate it. So was it marked wrong? So in perceptron, I don't exactly remember which. I think in perceptron the convention used is +1 -1. These are the two outputs, not 0 and 1. That's why it has been given as wrong. For some other algorithms like logistic regression, and also for some other methods like MLP, generally it is 0 and 1 class, but in case of perceptron is +1 -1 class. So you have to write y equals -1, not y equals 0. Step function gives output 0 and 1. I mean, we can adjust step function to give output -1 and +1 also. Just adjust the shape of the step function a little bit. Just take it little downstairs, you would get -1 and +1. You can have any kind of output from step function, but perceptron specifically, as far as I remember, it is +1 and -1. These are the two output classes. not 0 exactly. Some many other algorithms would use 0 and 1, but not perceptron. Okay, so thank you. Question 5, delta W2. Delta W2 would take a lot of time and a lot of calculations. I also don't exactly remember what would be the exact equation for delta W2, but it has been calculated in the lecture videos step by step. You can go through that. First you compute gradient with respect to W3, and then you use that to compute gradient with respect to W2 using backpropagation. I don't think there is any question regarding that in the third assignment also, delta W3, because it would take a lot of time to compute. Okay, thank you everyone for joining. We will again conduct a live session next week.